it's my great pleasure to introduce Eelco Visser from TU Delft. Eelco is basically very famous for making a Spoofax platform, which is a language workbench. So when I asked people around who to invite for the external DSLs, it was basically one answer from everyone. So and we really tried to get Eelco here, so we are really happy to have him. And I guess I don't need to explain Spoofax a little bit better than me. So all right. Enjoy.
Thanks, Eugene, and thanks for inviting me. You did make an effort, but I'm happy to be here to show you this. Well, to be the representative of external DSLs, I think, right? I mean, that's a big job. And so I thought a bit about it. The suggestion was to sort of give an overview of the field, but I'm not going to do that. I'm going to talk about how we do it in Spoofax and go a bit more in depth, because I think that's more interesting. So the title of my talk is Declare Your Language, which is a reference to, what's his name, Razvan? Hack Your Language course, where he does DSLs for things using programming. So what we're trying to do is to do declarative language definition. So define the various aspects of languages using declarative meta DSLs and derive from that an implementation of various, the various aspects that go into an implementation, a parser, a type checker, compilers, and so on. And so on that idea we have built, we have an ecosystem called MetaBorg that contains a bunch of these meta languages. So there's SDF3, which is a language for syntax definition. There's NaBL, which is a language for name binding, TS for type systems, and Stratego for transformation. And there's a new one that's called DynSem that's not yet released, but I'll try to talk about it, which is about dynamic semantics specification. And the idea is that these meta DSLs try to cover a particular part of the spectrum of language definition and capture the concepts, the domain concepts of that particular domain and then be able to generate implementations from that. Another thing we try to do, but we're not quite doing, is then proving properties of such language definitions. For instance, we aim to prove type soundness of the combination of a syntax definition, a type system, and a dynamic semantics. And then we hope to be able to get implementations that are verified. But I'm not going to talk about that aspect today. So what I'm going to do today is, well, it's after lunch, and I'm going to put you to work. So in the first part of this lecture, we're going to do a hands-on Spoofax tutorial. I hope all of you downloaded Spoofax and the right. So there's instructions on the program that have a link. So there's a Spoofax zip, and then there's a tutorial project that we're going to be using. And we're going to explore syntax definition with SDF3, transformation with Stratego, and name and type analysis with NaBL TS. And maybe we'll get to DynSem part. And then, as Phil said it nicely, theory is the stuff we want. So a particular bit we've been doing theory about is this name binding area. So we'll see in a bit how it works. So the concern is there, you want to describe the name binding rules of a language, and then you want to get all sorts of tools out of that. For instance, reference resolution in an IDE, right? So you control-click on an identifier, and you jump to its definition. So we built a nice DSL for that aspect, and we generated implementations from that. But sort of this DSL grew organically, sort of evolving with our understanding of the domain. But, well, there were some difficulties with that implementation, and when we were trying to publish about it, said, well, yeah, this DSL is nice, but what is the semantics of this name binding language? And so we've been developing a theory of name resolution, and that is a theoretical talk I would like to do in the second part. But maybe we have so much fun in hacking, we keep doing that. We'll see how it goes. If everything breaks down early, then I'll just skip to theoretical slides. All right, so I looked at the program, and I saw that Matthew was going to do QL tomorrow, and I said, yeah, that's actually a good idea because it's a DSL, and we have done QL in Spoofax. So last week I switched to say, well, okay, let me do QL as well, but then it didn't show too many things. So I switched back to the previous project, which is not a proper DSL. It's just a little programming language. But we'll be seeing meta DSLs, so that's my excuse. So we will still be seeing DSLs at work, but the actual language we'll be doing is a programming language. But these techniques apply just as well to DSLs as they do to programming languages. And so this particular language is, I've called it PeppleJ, but its author is Sriram Krishnamurti, who has written a book on programming and programming languages, which is a teaching book for concepts of programming languages. And it is a little subset of Java. So you can write classes with fields and methods and an expression that you execute. And of course, Sriram implements his languages now in Pirate, but the languages he implements are still parentheses languages. And I use this material in my course at TU Delft. So I have an online tool for doing web programming in which the students program in Scala, and we have translated Sriram's PEPL material to Scala, so we write interpreters in Scala of these parentheses languages. And the final exercise of this book is implementing this interpreter for this Java-like language. All right, so then I did a little exercise for myself, which is let's translate this PEPL language to a non-parentheses language, but with a syntactic language. And that's the exercise we're going to do today. So this maybe look a bit more recognizable, right? So we have a program with a list of classes, and classes have a list of fields and a list of methods, and then we have a single expression that is supposed to run the program and that can refer to classes in the declarations. And so what we're going to do is build an IDE for PeppleJ. And so what does that involve? Well, it involves defining a parser with error recovery, defining a pretty printer because we want to format programs, doing syntax highlighting because we want pretty colors in our programs, and then we want an abstract syntax out of our parser so that we can do transformations on them and name analysis and so on. Given that AST, we are going to do a little bit of desugaring using transformation rules. Then we want to do name binding, so we want to define the name binding rules of this language so that we can click on counter here and jump to its definition over there. And if we misspell counter, we want to get an error message about it. And then we want to have some type rules, so if we mistype the expression that we give as an argument to a method, then we get an error message about that. And finally, we want to give this language a semantics, so a dynamic semantics, and get an interpreter from that. So traditionally, in language workbenches, languages have been implemented using code generators, so compilers. So typically, what we do is make a translation from an AST to program text in some target language. But we've started exploring deriving interpreters from dynamic semantic specifications. For one, because that looks an interesting exercise, and I told you before, one of our longer term aims is to prove consistency of language definitions. And often what you see in language workbenches is that you have a nice syntax definition of your language, you have a type checker, and then you have a code generator, but nowhere do you have an actual specification of the semantics of your language. So it's not really clear whether the code generator you built, the compiler you built, does something sensible. Well, it is sensible by definition, right? It's the thing that defines the semantics, but then reasoning about that it's often pretty hard. So that's why we want to explore giving the dynamic semantic specifications, and then, well, it would be a shame if you first define the dynamic semantics and then have to still write a compiler. So why not generate an interpreter and hope that we can get good performance out of that? That is very much work in progress. I mean, everything I'm talking about is work in progress because we are developing these meta DSLs and their implementations and their formalizations. All right, that's it regarding slides. So now we go to your. You can open your laptops. And what you should then have is something like this. So so you open Spoofax. Do you still need links to this repository? So who has downloaded the all the files? I see 5 hands, 6. Good. Okay. It doesn't work. That's always a good start. So what is it?
JRE error 13.
All right. So what you should have is you should have your Spoofax zip and unpack that. And then, and that contains an Eclipse application. You open that, and then you get the error. And if you say again?
I can change the mode, the text.
You're on Linux, or?
Yeah.
Okay.
It's a mismatch between libraries, and you have to go into the Eclipse configuration and manipulate the Java that's already installed.
But it should, I mean, it should have a Java that comes with the installation, right?
It doesn't have execute permissions.
I saw the same problem.
Well, you set
Okay.
execute it.
Oh, it depends on your unzipping program. If your unzipping program doesn't deserve.
Ah, yes. We heard that's an error, right?
No, so on OS6 we have the same problem if you use the wrong unzipping.
Just change the permissions and you're good.
No, change the permissions, I get the error.
Can you help me?
Yeah, I'm not too proficient on Linux.
It's the same.
But it's a zip file, it doesn't have permissions.
No, but the files in the.
No, the files in zip don't have permissions. If it was gzip, it would have had permissions. But zip files don't. But that's okay, I had the permissions now, but it doesn't run.
Have you set the plus X permission to bin JRE Java? Because that's what
I see. No, I can do plus X on the bin JRE.
Yep.
every time I start Spoofax, this I get an error message saying that it needs minus XSS8M, 8 megabytes, but it's actually by default is set to 16.
Okay.
Yeah, this is the error message.
Right. Oh, I should get my my glasses. But did you get it? You got the zip thingy.
Yeah,
But that should have that information. That should.
Yeah, exactly. This is an error it gives me every time.
Okay. When you start, or
When I
it's a one-time
start,
error. Right.
Even though
It's set higher.
It's set higher.
And what about? But after you click this away, does it? Can you work with it?
I click it, don't worm me, and it still gives me.
But only on startup, right?
Only on start.
Yes. Okay. Let's ignore it for now. All right. So let's assume that works. Then there you downloaded the Git project that has the PEPL project. So from there you should import existing projects into Workspace, and then you select from that whole project, languages, the PEPL-J directory. All right.
So in GC compiler for importing the procedure, that's expected.
That's expected.
What is it?
So here, like for these things. So
Yeah, that's fine. This is perfect because I mean it gives you errors because that's what we have to fix, right? We have some work to do. Right. So you select this directory, then you do open, and it gives you a whole bunch of these projects, and you say select all of them. I already did that, but then right. And then you do finish, I think, and that should give you this, basically, right? So you have a whole bunch of projects, and they're probably all open. So now what you could do is go to PEPL-J syntax, and right-click, and say close unrelated projects, or you can also close all the other ones manually. Right, close unrelated projects. Yes, I'm sure. Okay. Yeah, and then you should have about this picture. And then you may open PEPL-J syntax exercises. That should give you a directory with SPT files. And then open the second one, the numbers one. And then you do, oh yeah, another thing you want to do is if you have built automatically on in the project menu, turn that off, please. Okay. If you've done that, then please build the PEPL-J syntax project. All right, so what are we looking at here? This is module, I should probably rename that into 1.2 numbers, which is an SPT file. And SPT stands for Spoofax testing language. And it's a language in which we can specify less tests over the languages we built. And so what we're doing here is saying, well, the language we're using is PEPL-J. The start symbol we're interested in is expr. And then we define a bunch of tests. And between the brackets, we have an expression fragment, so a text. And then we have a specification. And here we say, well, what we want to do with this fragment is parse it. And we want to parse it to this particular AST. Right, so 1 should parse as num1, and apparently it does. And there are some other tests that succeed, but then we also have some tests that fail. For instance, the test for sub fails, and if we hover over the test, it says fails to parse. And if we then hover over the fragment, it says syntax error not expected here 1. So it cannot parse this fragment. But there's a specification. Right? We want this particular AST sub of num1, num2 out of this fragment. So let's look at fixing that. So we look at the PEPL-J syntax project. We open that, and we look in the syntax directory, and there's a expressions.sdf3 file. So let's open that, put the test next to it, and here we see how syntax definition in SDF3 works. All right, so we have a module called expressions. It imports some common stuff, which we'll look at later. And then it defines a bunch of context-free syntax productions. And they're BNF-E. So what's going on here? We see productions with a non-terminal that we're defining, a body that is the thing that is the body of the production, and this num thing here, that's the constructor. That's the AST constructor that we're expecting that we want to build for this fragment. Right, and that is nice, and that corresponds to this first test here that says when we parse an integer, then we get an AST with constructor num and the lexeme, the token string 1. Okay, and and there we can do the obvious thing. So let's build an expression, the syntax for unary minus and for binary plus and multiplication, and I do the expected things. So why don't you go ahead and open this file and see if you can make the tests in this file work by adding more productions. And feel free to ask questions.
Anyone need help setting up?
Yeah, so Daco is RTA.
There's got to be a lot of climbing.
That is the height of Saturday.
So I'm still getting this error here. Maybe I have to do clean or something.
What is the error? Let's see. Did you build the project first?
Yeah, I did build.
Build again?
Maybe I have to build it again.
Okay.
Project.
I copy pasted the one.
Okay, maybe.
It wasn't there. Yeah.
Okay, maybe now it's fine. Okay, I'll let you know.
How do you run the test? So after you build the project, the test file that is open will just re-evaluate. But you can also force the test to run. So if you go to the test file, it should have a transform menu up here. And that has a run test suites or run test suite current file. And if you do run test suites, it will run all the tests in the current test project. Right, and we see lots of failing tests, as would be expected. Right, but after you change your syntax definition, you have to rebuild your project. I'm sorry? Yes, you rebuild the syntax project. So if you change your Spoofax definition, so the syntax or other later things we do, if your cursor is in one of the files of that project, then you can do Command Option B or project build project from the project menu. Okay. And if building, and in the console you should get a report about the build, and it should end with build successful at the end. Right? If you see this, then supposedly that's things worked out. So maybe instead of saying get everything to run, let's say get the multiplication test to run.
How do I say I want a repetition? So I'd like to say experiment.
Well, so what I would suggest now is follow the example. Right, so we have addition. Can you do multiplication as well?
Yeah, I did those.
Hmm?
I did those.
Okay. Oh, but you're trying to do the do.
The block.
Right. Okay. 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 So let me do that, and then we go to the block together. So this is pretty simple copy and paste programming, right? Subtraction has the constructor sub and the operator minus, and multiplication has the asterisk. And if we build that, save and build that, we should have those tests succeed. So let's have a look at the block definition. So what is a block like? Well, a block is a curly braces and then a bunch of a list of things between them. And so what we want to do here is say something like this. So it's curly braces, and so the general pattern that you are observing here is that for the body of a production we use quotation symbols, right? So the square brackets quote a so-called template, and everything in that template is literal text that is considered as literal. So the plus here is taken as literal, except for the things that are anti-quotations. So if we use another bracket, then we do an anti-quotation, and so here we're saying use the X per non-terminal, right? So here we're saying X per non-terminal plus literal and another X per non-terminal. We can also say do repetition. So we in this production we say, well, we want a list of expressions. So we do anti-quotation of X per and then clean a star of that X per. So that gives us a list of expressions. But that's not entirely what we want. Because it seems like these things are separated by semicolons, right? So then you might be tempted to say something like, well, to start encoding this, but in SDF there's a convenient notation that says, I want a list of things separated by something. So rather than saying, well, this is a tuple that is repeated, it is a list with separator. And if we do that, we see that our block tests succeed. Well, at least some of them. And there's an issue here because what I wanted to achieve here is have a, so this language has blocks that are basically sequential compositions, and they're separated by, and the expressions are separated by semicolons. But well, the typical convention is that you want to be able to finish them using as final delimiters. So what to do? Well, so one thing to do is there. Well, yeah. So what I did is do this. So let's make up a notion of a statement that is just an expression, and then have a special kind of statement called skip. And skip just is a semicolon. And then I define my do as a list of statements separated by semicolons, and then I can also have a skip statement. Right, so now I can end my list of expressions with a semicolon, but only in the context of this do statement. Right, I cannot use semicolon as an arbitrary expression. And why is this an issue? So let me show you another way to use Spoofax, which is to, so we're defining these tests, and that's very useful as a sort of to build up a set of regression tests. But of course the final goal is to get a working editor. So from this syntax definition, what we get is a is an editor with that uses the generated parser to check syntax. And I'm doing here. Right, so what I can give in such an editor, I get a syntax menu up here, which I can use to give me the abstract syntax tree of the editor. So I have to put it here. I can sort of experiment with what is going on. You see that the abstract syntax view is updated as I type in my program. And it is complaining about the semicolon. And why is that the case?
So how did you get the A term?
I'm sorry?
The doodle A term, how did you get that?
Okay, so I go to the doodle.pj file. There's a syntax menu, and it has a show abstract syntax entry, and that gives you the A term file, right?
Anyone needs help, just raise your hand. I know where you are.
All right, I'm confused about this error. We'll, huh? Oh, that is the thing. Yes, I suppose you're right. Thank you. Is that it? Yeah. That was the idea.
Did anyone else have JVM terminated exit code 13?
Thanks, Oscar. All right, so we're making progress. So these errors are not so much about the blocks as they are about another test file because we have no syntax for Booleans. Can you figure out how to add Boolean expressions? That's not hard. I mean, it's not a trick question. You cannot. All right. So let's move on and do a few more of these things. All right, so we can define some syntax for Boolean expressions. What's the syntax for? Right, and we just plot on and you should be getting the idea by now, right? Yes?
What is the difference between putting true in double quotes and using this this way? Because it worked for me with just putting
Yes.
in double quotes false.
Mm-hmm. Yes, excellent question. And well, actually, so we can, for instance, write this production also in this style. And these are basically equivalent when it comes to parsing.
So you basically use them to quote unquote.
Yeah, it's sort of a different quotation style if you want, right? So the at this level, if we're just talking parsing, it's just a quotation style. Either we say so the idea is with the quotation style is we sort of quote an example, right? Like this, and you say, well, that's a piece of code, and from there you generalize, saying, well, but we don't actually want true, we want an arbitrary expression. That's sort of the style here. But really, they're just context-free productions in this format. Okay. But now here's a thing. So let me build this and let's have a look at the doodle. And because in the syntax menu, in addition to show abstract syntax, there's an additional entry which says format. And let's see what that does. So format takes the AST generated by the parser for this program and then pretty prints it. Well, this is maybe not entirely pretty. So we may want to do something about it. So what's not so pretty about this? Well, we say, well, let's say we want to put the statements on separate lines, and we want to have the curly braces on separate lines, and then we want to separate the statements by new lines, and we don't want a space between the statement and the well, let's say we also want a space between the statement and the semicolon. So now if we build this again, we are getting, our formatter should be updated, and the idea is that it takes hints from these production templates, not just for parsing, but also for pretty printing. Right? So it interprets these it interprets the template to derive a pretty printer that makes a mapping from ASTs to text. Well, actually, it makes a mapping from ASTs to so-called box expressions, which are then input for a formatter. Which, yeah.
So in the definition of this view, you're using this semicolon \n for two purposes, and for the purpose of separation, you just ignore all the white space.
That's right. Yeah. So there's a bit of magic.
Yeah,
that's right. Yeah, so
one thing for two purposes.
That's right. So there's a bit of magic here that says, well, when we're parsing, we translate the template basically to a production like this, where we say, well, we just have brackets, and we have a list of statements separated by semicolons, right? But then. The white space is then interpreted as hints for the pretty printer, but ignored. There's actually an idea where you say, well, we could also interpret the white space to get white space sensitive languages like Haskell, right, where you use the indentation as mandatory for disambiguation. Well, we don't at the moment. So currently we are ignoring this, but it might be. So we have an extension of SDF which I'm not going to show today, which does use layout constraints, so in order to specify white space sensitive languages.
So you cannot have brain fog.
I haven't looked carefully at it. Yeah.
Okay, great.
You're saying that's an advantage, right? Not a disadvantage.
Yes.
So is box expressions and expressions the same kind of similar thing to document?
Well, we can actually have a look at it. So if we look at the source gen directory, we see a whole bunch of things that are generated. So I think what you should get by now is that just from the syntax definition, we get an editor with syntax highlighting and error recovery, right? So if I do some mistyping here, it will, let's have a look at that. Right, so we have a syntax error, but we still get the AST. Right, so the is it updated actually? Let me wait. This is the pretty printed version. So I shouldn't. So let's check if that's true. So let's get the AST. That's the same. But now if I update my text, you see that the AST below is being updated automatically. But even in the case when I make a syntax error, you see that the AST gets updated because there is a parse error recovery at work that still tries to do as much as it can, and at some point it will not be able to do quite as much. And wow, okay, right. So now it's throwing away a lot of things. Right, so you get a parser with parse error recovery. You get an editor that checks for syntax and reports syntax errors. We get syntax completion, so it will suggest possible ways to complete this program based on the productions. And actually, let's see. Right, and it uses again the white space indications from those templates to put white space in the completion templates. Right, and we generate, let's see, an algebraic signature.
How did it know to put those on different lines? Where's the information?
I'm sorry?
How did it know to put that on different lines? Where's the information about that?
That's in this template over here.
Oh, I see. Okay.
Right, so that's so we use these templates to give hints about white space. That's used for pretty printing, but also for these syntactic completions. Right, so the typical case is of course the if, right, where we say what does that look like? If not actually sure what our if expressions are supposed to look like, but something like that.
Yeah, but then we don't have
So what we also generate from these productions is an algebraic signature that sort of describes the constructors and their types. So that basically describes the AST structure. And that is because we have all the information of the AST basically in the productions. And we generate an implementation of a pretty printer, which is basically rewrite rules that take the concrete expressions. Let's look at our do thingy. Right, it takes a do and it creates some weird AST expressions in a so-called box language that give instructions to a pretty printer formatter to put these things together and generate a string.
Is this to illustrate Martin's point about DSLs sometimes being impenetrable?
No, this is to illustrate the point that from a single, so Phil, let me repeat your question. So you're saying Martin's point was that DSLs are impenetrable, and that is illustrated by this example. And so what we're seeing here is plain rewrite rules that rewrite an AST expression in one language to an AST expression in another language. And but indeed, these are not the kind of the rules you would like to write yourself. So we generate them automatically from the single syntax definition we are writing in SDF3, right? So right, the rule, the pretty printing rule like this is generated from our definition of if over here. So in addition to generating a parser, we also generate pretty print rules, and which indeed are the kind of rules you don't want to write because they're sort of the exact dual of the parsing rules, modulo the white space, right? That's the nasty part about pretty printing. Yes.
So if I understood correctly, so somehow those rewrite rules are going from like a DSL, let's say, in which are somehow for expressing ASTs or expression terms, to a DSL which is somehow similar to document document abstraction.
That's right. That's right. Yes. Yes, these rewrite rules, rewrites, I should repeat your question. So the rewrite rules rewrite from an AST according to the language we've defined in SDF3 to the AST of a language for formatting. So basically a library for formatting. And that's, yes.
Regarding this, I have another question. I imagine we could have two different rewrite rules, one for pretty printing and one for something that we'd like the AST maybe to look different. Could that happen?
Yeah, so the question is, can we have multiple rewrite rules to rewrite the AST to different things? And definitely, we don't want to just build ASTs just to rewrite them. So we do want to do more things with them. And we'll come back to that. We'll see other examples of rewrite rules. Yes. So there was a question about these completions. Right, so the other thing we do is, in order to generate these, an editor that supports syntactic completion, we have a little DSL for describing these completion templates. So when we first built Spoofax, we said, well, okay, we need syntactic completion, so we need to declare them somehow. And so based on some trigger, you want to generate a whole bunch of proposals for syntactic completions. That was very tedious to write, and that's why we came up with this template language for syntax so that we could automatically generate these completion templates. And yeah, so that's sums it up so far. So what we do with a single syntax definition, we generate a whole bunch of things. Yes?
So you're generating first, again, domain-specific language files to get all the stuff done. So basically we start with one file and you generate a lot of files that are also domain-specific. Is there another translation step that translates them to Java code for Eclipse, or is there some implementation happening?
So the question is, you generate two other DSL files, and why not generate to Java? And in fact, these ESV files are interpreted by our IDE framework, and why have them at all? You could say. Well, maybe you want to write your completion. You want to write custom completion templates, right? So that's where you can do things beyond or in addition to the automatically generated ones. So these signatures, for example, are signatures that we use in the Stego transformation language. So they're actually read as part of the source code, and the same for these pretty print rules. Yes.
So these things about for completion, they are automatically generated. So if we want to extend them, where should we extend them so that they're not overwritten the other time that we are
Right. So, yeah. So, well, so there's more ESV files. So, for instance, you can. Do we have an example here? That actually doesn't parse. Well, I was going to show folding, but we need a bit more interesting example for that. Maybe. We don't get folding. All right. So there's other things that are generated. For instance, the coloring. You may want to adjust the coloring, and so we generate a default coloring, which just gives you a kind of an Eclipse style coloring. But you may change those, and we have a generated file. But you can also write your own, and those are not overwritten then. Right? So, and the same for the completion template. So you can. It's basic. What is the pattern? Well, you have a generated file that you don't touch, but you don't want to mess with generated codes. All right, so that gives us basic features for expressions, and maybe some of you have gone a bit further with these expressions, but now let's have a look at another test file. For instance, combining operators. Fails to parse. Why is that?
You're stuck somewhere. Raise your hand, because otherwise I don't know that you're stuck.
So first of all, this fails to parse because we didn't define syntax of identifiers. So we just add that. Actually building. All right, so this is nice. So we get, well, we didn't do all the operators, but we do get things like not of x and y, or not x or y, and x plus y times z, and it all works pretty neatly. So let's go to the next test, 1.4, where I have basically the same expressions but without using parentheses. And these tests fail. So what's with that? So if I hover over the test, it says syntax is ambiguous. That's weird. So let's copy one of these tests and go to our Doodle file and paste this expression. And indeed, it will report an error where the message fragment is ambiguous, either and or not. So if we want to know more. So let's go to show abstract syntax. And whoops. And this is what we get. So can someone explain the problem? We didn't define precedence, exactly. Okay. So how would we do that?
Precedence equals 5.
Precedence equals 5. Exactly. So here's a little cheat. So let me copy that over into my file. So what I've done here is encoded the precedence. That's neat. Right. So I say, well, I have an expression level 0. That is parentheses and identifiers and literals, and then the next level. So that's the closest. Yeah. Oh, you have okay, right, and then plus binds less strong than times and so on, right? So this is solve our problem. Does it? It doesn't, because I have an error in my file. All right, nice. So this solves my problem. All right, so now I have a non-ambiguous syntax and not binds stronger than and let's look at our tests. Question.
Why you should this approach other and not giving no explicitly saying for each operator this is the precedence?
Why would you prefer that?
Yeah, just the question. What's the
So I'm curious for your answer.
more more straightforward? But, you know,
Okay.
when I saw the previous solution, I said, okay, I had an attribute, for example, precedence over each operator. I would have said that precedence is false. So what is the?
That's right. I mean, you're completely right, and that's what we actually do. So this was a just intermediate example of how you can do it. Right? So you can encode precedence literally by using different non-terminals to encode the precedence levels. But this is pretty tedious because you have to remember the right levels. You have to look at how associativity and precedence works out. And if you want to add a new operator or a new precedence level, you may have to renumber all your levels, and then you say, well, let's use term and factor, but that's you have to come up with new names, right? So that's all pretty tedious. So the previous grammar we had was pretty nice actually, right? So it was it just expresses sort of the abstract syntax structure where we say, well, an addition expression is an expression plus an expression. We shouldn't worry about left recursion or right recursion or whatever recursion, or right, and we just want to. Because now the production corresponds directly to the abstract syntax, right? And this is how you want it in theory. You want to say, well, here's my abstract syntax. I don't want to worry about ambiguity. But of course, in a practical parser, you do. And so what you should have seen is that in this framework, when you do have an ambiguous parser, well, you don't get a parse conflict thrown at you, or saying, well, I don't know what to do with this. You can actually get a parser and you get to see how it parses it and where the ambiguity occurs in your program, right? But then you want to do something about it, and what we do, rather than encoding these precedence levels explicitly or numbering them, we have declarative and relative precedence declaration and associativity declaration, where we can sort of annotate productions with their associativity. So we're saying, well, this is left, we could, I guess this works as well. And this is left associative, and that is left associative. And then I think if you have, let's say, exponent, I think that's right associative, right? No. So that covers associativity. In addition, we also want to declare precedence, and in order to do that, we can define the relative precedence of operators. So, for instance, we can say negation, or and let's say minus binds stronger than multiplication and division, which binds stronger than addition and subtraction, I think. And here we see that we get a little help.
No, it's mul. L in the mul.
L in the mul
above in the definition.
There you see, that's consistency checking for you. And you see, well, you get navigation here and so on, right? So you can, we didn't actually define division, so. Is division left associative? Another. Something like this. Well, and the Boolean operators bind even, let's see, export and I'm sorry, why not?
Why did you define multiply? Why didn't you define multiply as a feature? Because you can have A times B, B.
I don't get the question. I'm sorry.
For the definition of the multiply, you said it's left.
Oh, instead of associative?
Yeah.
Yes. I'll reveal a secret, and that is that post-hoc is basically left, but that's. But this is a more semantic expression, I guess. That is not that we don't actually use. But,
so maybe later you use that. Right now.
we might, but we don't. But yes.
I notice it doesn't do somehow of a check. My grammar is in the end non-ambiguous.
That's right.
Right.
Do you? So the question is, there's no check that checks whether the grammar is non-ambiguous.
Yeah, I'm guessing it can be verified without tests, right?
And the proposal is that this can be verified.
Yeah.
Audience.
What can be verified?
That the grammar is non-ambiguous.
Oh. You may say
Remember your.
But you may say it's undecidable, but it's still this.
Right. So okay. So yeah. So the property whether context free grammar is unambiguous is undecidable in general, but there are tools that do approximate it and try to find counterexamples and so on. And indeed, and those are quite interesting, and we could integrate them in the workbench. Yes.
So there is nothing.
We don't do that now.
We were talking about what kind of grammar are you writing? Is this a full context-free grammar, or is it some subset that is linear time possible?
No. So what we're doing here is full context-free grammars.
Okay, so in worst case you need cubic time parse text.
Yeah. So well, and what we're doing is GLR parsing,
Okay.
and it's even worse because we're doing SGLR, so scannerless GLR parsing. So in fact, the lexical syntax, which you haven't asked me about yet, but let me tell you about it. So the lexical syntax is defined in the same formalism as the context-free syntax. So right, rather than having sort of a tokenizer and a grammar formalism, we have a single formalism. We still do declare things as lexical syntax versus context-free syntax. So what is the difference? Can you, I ask you, what would be the difference between lexical, why do we still declare context-free syntax and lexical syntax? Yes?
Maybe because lexical syntax can be interpreted faster for syntax highlighting.
So the answer is maybe because we have some freaky optimization. No, that's not the answer. We could have, but yes?
I guess it is not reflected in the syntax tree. So
It's not reflected in that. That is one aspect. Yes, absolutely. So what we in what you saw in the syntax tree is that we what we do with lexicals is we when we go from a parse tree. Well, actually, what the parser does, it first constructs a parse tree that is completely faithful to the underlying grammar, including the lexical syntax structure. But then typically when we do transformations, so we are not interested in the structure in lexical syntax. So what we do is just implode lexical syntax to trees to strings. That's part of it. But there's another aspect to it. And that is something that is quite implicit in these productions is, well, here you see there's something between the expr and the plus, right? There's a white space. And I said before, well, but in these templates, they're really equivalent to this, right? And plus, where plus is lexical syntax. But in fact, there's something in between, right? Because when I write a plus expression, I can write a space between them. But I didn't specify that in my grammar, actually. So that's sort of implicitly there. And so what happens is our syntax definitions are actually transformed to things of this form. where everything is made excruciatingly explicit. Uh-oh. Shouldn't have done that. Oh, this is probably CF. Right, we're saying, well, between the X per non-terminal and the plus literal, there can be optional white space. Right, so this is a transformation that we apply explicitly to the transformation from context-free syntax and lexical syntax, and we make all these details explicit in the grammar. And then we have a grammar that we can use for scannerless parsing, because in scannerless parsing you need to account for, you don't have a tokenizer that filters out the white space before you start parsing. Right? You do recognizing of white space and so on and comments as part of the parsing process.
Is this legal grammar or is this like highlighting broken?
This is a legal grammar, yes.
Because X per minus CF looks off.
Yes, because CF is a modifier basically. It's an operator on grammar symbols. So what we're doing is in order to distinguish a namespace between non-terminals used in lexical syntax and context-free syntax, we mark them. So we could also say, well, there's a lex thingy there. So that's a bit technical, but the idea is that a grammar is normalized to a kernel grammar that makes lexical syntax and completely explicit, and the parser then operates using characters as its tokens. And so these okay, so the difference between lexical syntax is, so what we do with context-free syntax is that we interleave symbols using optional layouts, right? Because that's the characteristic of, and we don't do that using lexical syntax because we don't want a white space between the characters of an identifier, right? And the other thing that we use that you typically only use in lexical syntax is character classes. Here we can say, well, use the class of lowercase and uppercase letters, but.
So doesn't that space there mean allow white space between the first letter of an identifier and the other letters?
No, because the difference here is that this is a production in the style of, non-templated. Right, so in these template productions, we're saying, well, here's a template with white space and so on that we interpret. But this is just a sequence of symbols, and the white space has no meaning. Does that make sense?
Yeah, you answered the explicit question. You didn't answer the implicit question, which is how on earth do users keep all this straight?
Well.
Yeah, this lexical syntax and arbitrary syntax, I think this plays a role here, right?
Yeah.
Because this lexical syntax then is quite.
No, so okay, so so this space over here is not saying I want white space here. That's just a space between two symbols in my language. But the semantics of the language says that a production like this is transformed to a production like the one I showed you before, where I explicitly interleave the symbols of a context-free syntax production using white space or layout. Is that? So that is
To build my external DSL, I use another DSL that translates to other DSLs.
Well, you do normalization all the time, don't you? So we have a sort of a high-level language where you abstract over details that are boilerplate details. Like I want to.
No, I think it's actually very attractive that you just write these things in brackets and you get both the parser and the pretty printer, and that you manage to build in a lot of knowledge about how white space should be handled for things like the pretty printer, which I think that is very helpful.
Mm-hmm. Good. Should I repeat that for the record?
Sure.
So Phil thinks it's useful. Good. I'll frame that. I think that basically covers it. Oh, well, yeah. All right, so let's close this project. Close project. And let's open project, what is the next one? Transformation. And so there we're going to do some transformation exercises, but actually it also has to complete grammar, and that is useful because then we can look at some what it looks like when we're done. No, that's fine because we may still want to test against those. All right, so this is what a complete expression grammar looks like. Right, so we have productions for arithmetic expressions, booleans, and comparisons, and if, and we have blocks with our skip thingy. And we have let bindings, and it basically looks like you would expect it to do, right? I mean, the point here is that you want to abstract from sort of you want to write productions that look like you would write them for defining an abstract syntax definition, and not think about the details of a parsing algorithm, whether things should be left recursive or some such, right? So there's much more expression syntax. So it's an OO language. So we have field get and field and assignment to a field, and we have method calls, and we can create new objects, and we have a this, and we have a null, and etc. And we have type expressions, and right. And I hope you, yes?
Why do you need to repeat the context-free syntax in between this block?
You don't need to. That's just my my hang-up. So I use these things as sort of section delimiters to. So well, this is the syntax for objects. And, all right. So the other thing you should. Okay. So there's a few details that I said. So one thing is reserved words. So this is we do scannerless parsing, so that means we cannot use tricks like if you see the token definition for the if keyword before you see the token definition for the identifier keyword, we prefer the if keyword over the identifier if, right? I mean, that's a typical thing that is done in definition of scanners. And so what we do here is we have so-called reject productions, where we say if we recognize an identifier as one of these keywords, where these are the keywords, then we may actually want to add if and so on. Then we reject it, and that makes sure that we cannot parse things. Well, that's. I should, in the meantime, build this. Hmm? I'm sorry? That's right, that's right. Because now if we didn't had this kind of disambiguation, then we would. All right, so let's if we turn this off, then we get an ambiguity that says true can be an identifier or it can be the keyword true. Right, so it says ambiguous, and if we say show abstract syntax, it tells us true can be either the true AST or it can be var true, and this can be a feature, right? So we don't build in that all the literals you use in your grammar productions are automatically reserved words. So you can design it as a policy that rather than making that the required feature of your languages. Right, so you can, I guess in our language we have, Right, so I didn't declare if as a reserved word, so this actually works. So you might decide, well, this is not what you want, and you declare it as a reserved word, but so there's this flexibility to come up with these kind of policies. The other little issue with scannerless parsing is that you don't have automatic greedy matching. So if we would, for instance, make this language functional and say we have an application operator, right, where we can apply an expression to an expression without parentheses. And then if I say I have the expression xy, what do you predict will happen? Well, okay. I didn't set this up right. So it will not be an ambiguity because I've declared that a so-called lexical restriction that says an identifier cannot be followed by one of the characters that make up an identifier. Right. So, and if I remove this, then the other alternative I get here is that I can have an app of a var x and var y. And so this is so this bit of SDF can be a bit tricky. All right. Any questions about syntax so far? All right. So let me summarize. We have a declarative definition, I assert, yes.
Were you able to bootstrap to your language, in your language?
Absolutely. All our languages are defined in SDF3, and yes, we wouldn't want it any other way. Right, we define syntax definition, and by the way, they're modular, right? I mean, well, you can divide your syntax definition into modules. It is not actually modular in the sense that we have separate compilation for syntax because generating parse tables. So we generate LR parse tables, and that's a non-compositional problem, unfortunately. All right. So how are we doing for time? Are we ready for a break already?
Break is scheduled in a minute.
In a minute? Shall we do that? Let's do that.